Hi guys, welcome to the lesson of partial differential equations. So in our previous lecture series, we discussed about the first order partial differential equations. We discussed about the linear, semi-linear, causal linear, and the nonlinear partial differential equations. So now from now onwards, we will discuss about second order partial differential equations. So before going to solve the problem, first of all, we will talk about the classification of the second order PDEs, which is necessary before going to the solution of problems. So first of all, we will classify PDEs and then we will apply their respective methods of solution, right? So the classification of PDEs is same as the classification of quadratic equations. So in the previous classes, we learned about the quadratic equations and we saw that a quadratic equation that is given by ax squared plus bxy plus cx squared plus dx plus ey plus f is equals to 0 may be classified by using these coefficients of x squared, xy, and sorry, this is y squared, right? This is y squared. So the classification was done by using the coefficients of x squared, xy, and y squared respectively. So how we classified? We classified when b squared minus 4ac was equals to 0, we said that the equation is a parabolic equation. Right, when b squared minus 4ac was less than 0, we said that this is an elliptic equation. And when b squared minus 4ac is greater than 0, we said that this is a hyperbolic equation. Right, so in this case of second order partial differential equation, the classification will be done by the same method. We will check b squared minus 4ac either is 0 equals to 0, less than 0, or greater than 0, right? So the standard form of second order partial differential equations is given by AUXX plus BUXY plus CUYY plus DX plus EY plus FU is equals to G. This is not X, sorry, it's DUX. It's DUX and it's DUY and EY. So this is the standard form of a second order partial differential equation having two independent variables, right? So here the independent variables are X and Y, and the dependent variable is U, right? So we will classify these partial differential equations by using the same properties, using these coefficients A, B, and C. Rest of the coefficients are not important for the classification. So first of all, we will say that if b squared minus 4 times ac is equals to 0, the equation will be a parabolic equation, right? And if b squared minus 4ac is less than 0, we will call it as elliptic equation, and if b squared minus 4ac is greater than 0, so we will call it as hyperbolic equation. Right, so these are the basic classification of partial differential equations. There may be more classification when we go to 3 variables or 4 variables, but we are only talking about 2 independent variables in this lesson. So let's take some examples of the classical partial differential equations. So first of all, we will talk about the wave equation. It's the classical wave equation derived by D'Alembert, and what it says that t squared u or dt squared is equals to c squared times d squared u or dx squared. Right, so this u is basically the displacement of any string, and it's depending on time and the x dimension. If we are talking about only one-dimensional wave motion, so this is the equation, right? So if we want to find that either what kind of equation is this, it's elliptic, hyperbolic, or parabolic, so what we need to do is we just need to organize the equation by simplifying, taking all the equation to the left hand side. It's equals to 0, right? So now we can see that this is UTT. This implies that this is UTT minus c squared times UXX is equals to 0. Right, so if we compare this equation with the standard form, what's the standard form? Standard form is AUXX plus BUXY plus CUYY plus DUX plus EUY plus F times U is equals to G. Now, if we compare this equation with this standard form, we can see that A is 1 here, and this B is 0 here because we have no term of UTY, so B is 0, and again then C is 1 here, -1, sorry, because of this negative sign. So we can write that A is equals to 1, B is equals to 0, and then this C is equals to 1, right? This C square is just the constant. It's you don't need to be worry about this c squared. This is just another thing. This c is like in the standard form of this differential equation, right? So this c is just a constant in the equation. We can also write it as alpha square to avoid confusion, right? So we'll replace it by alpha square just to avoid the confusion, right? So, and yes, this alpha square is also there, so the c will be 1 alpha square because this whole is the constant, right? So this whole is the coefficient of uxx. Now we can apply the equation, that is b squared minus 4ac, and in fact this is negative 1 alpha square because of this negative sign. So we can, this implies that b is 0, so 0 squared minus a is 1 and c is minus alpha squared. This implies that this minus minus plus, this will be only alpha squared. So what our b squared minus 4ac gives in this scenario, it gives a positive value, that is alpha squared. So b squared minus 4ac is equals to alpha squared, and it's a positive value. What that means, that b squared minus 4ac is greater than 0, because alpha square will always be positive because of this square. Whatever value of alpha we plug in, that will give a positive value, right? So b squared minus 4ac is greater than 0, so it's an example of hyperbolic partial differential equation, hyperbolic second order partial differential equation. So the wave equation, the classical wave equation, is an example of uh, hyperbolic PDE, right? Because this b square minus 4ac is greater than 0. So now let us take the heat equation, the classical heat equation, and we will classify the heat equation as well. So let's do that. What's heat equation? Heat equation is nothing but it's just say that dou u over dou t is equals to dou squared u over dou x squared, right? So this u represents temperature and this t is time. That means that is the first partial derivative of u with respect to t, and this is the second partial derivative of u with respect to x. X is showing the x direction. Like if we are hitting a rod, like let's say that we are given a rod and we heated a rod, and then we remove the equipment that was giving heat, and the heat flow in this rod will be given by the solution of this partial differential equation, right? This is what it says. So now we can write it like this: dou square u over dou x squared minus dou u over dou t is equals to 0. It doesn't matter if you shift this dou square u to the left side or shift this dou u over dou t to the right side. It doesn't matter at all. So now we can see that if we compare, first of all, what's the coefficient of this 1, and the coefficient of this is also 1 and -1 because of this negative sign. So now if we compare with the standard equation, that is auxx plus buxy plus cyy and dot dot dot. So what's a here? It's a is equals to 1, and what's b here? B is equals to 0 because no term of uxt, right? We can write this equation like this also for our ease, right? So uxx, so the coefficient of uxx is 1, ut is -1. So b is 0 and c is also 0 because no term of utt, right? So there is no term of utt, so c is also 0. So now we will apply b squared minus 4ac, and we can see that this is equals to 0 minus 4 times 1 into 0, which is equals to 0. So b square minus 4ac is equals to 0 means this is a parabolic equation. All right, so the class of this classical heat equation is parabolic type PDE, right? Now we can move on to the classical Laplace equation, and we will see that what it says, what's the class of this equation. So this is also called two-dimensional heat flow equation, dou square u or dou x squared plus dou squared u over dou y squared is equals to 0. This is also called a steady heat equation in two dimension. We call it steady because its dou u over dou t is equals to 0. Basically, what it should be on the right hand side is dou u over dou t, but it is equal to 0. It means that it is in a steady state, right? It's in a steady state. Why we call it steady? Because the change in the temperature with respect to time is 0, right? So that's why it's a steady state. So what's A here? Let's write in the journal order to make things simple. So uxx plus uxy, the coefficients of both uxx and uyy are 1. So we can say that A is equals to 1, B is equals to 0 again because no term of uxy, and then C is equals to 1 again. So B squared minus 4AC will be equals to 0 squared minus 4 times 1 times 1, that is equals to -4, and -4 is less than 0. So this is an elliptic type of PDE. Right, so this is an elliptic equation because the b squared minus 4ac, that is also called discriminant, is equals to is less than 0, because in this case it's equals to -4. So this is an elliptic equation, right? So let's take some more example. Let's say that we are given with an equation 2uxx plus 4uxy plus 3uyy is equals to 0. So what's A in this case? It's 2. What's B in this case? It's the coefficient of uxy, that is 4. What's C in this case? Is the coefficient of uyy, that is 3. So now we can check it like b squared minus 4 times AC. This will be equals to 16 minus 4 2s are 12, and 12 3s are 36. That is equals to -20, which is less than 0. So we can call it as elliptic PDE. So you understand now how to find, sorry, this is by mistake. I write it as like this. Just a minute. It's actually 16 minus 24. Right? So in any case, it's negative and it's less than 0. So this is an elliptic type of PDE, right? So let's move on to another example. Now we talked about the coefficients that were constant coefficients. All the coefficients of the equation were constant. Now we will talk about some variable coefficients like x squared times d square y over dt square. Now we can see that how these types of equation works when variable coefficient is involved in the equation, right? So it's the same thing. First of all, we will write a. A is the coefficient of this. What's it? It's x squared. And what will be b? If there is no term of uxt, so it will be 0. And then there is this uxx with negative sign, so c will be equals to -1. So we can write b squared, that is 0 squared minus 4 times a times c. So it will be equals to 4x squared, right? So what does it mean? It's 4x squared. So this 4 is positive, and this x squared shows that this term will be always positive because of the square. Whatever value you just plug in this in the place of x, you will get always a positive value because of the square sign. So 4x squared is always greater than 0. So this is a hyperbolic partial differential equation, right? So now you see how it works when a variable coefficient is involved in the equation. Let's take another example. Let's say that a question is given like this: t times utt plus 2 times uxt plus x times uxx plus ux is equals to 0. All right, so only these three coefficients we need for the classification of this equation. So a is equals to t because it's the coefficient of this utt. B is equals to 2 because it's the coefficient of uxt, and c is equals to x. So apply the same condition, b squared minus 4ac. So we'll see that this is equals to 4 minus 4xt. Now, how we can conclude this equation? How we can make conclusion for this equation that is either it's a parabolic, hyperbolic, or an elliptic PDE, right? So let's take it 1 minus xt times 4 because 4 is common on both the elements, right? So if we can see that if 1 minus xt is equals to 0, it means that xt is equals to 1, right? So when xt is equals to 1, what will happen? This whole will be equals to 0 because 1 minus 1 is 0 and multiplied by 4 will be 0. So when xt is equals to 1, now it's conditional, right? It depends on the values of these variables because these are the variable coefficients. So when xt is equals to 1, the equation will behave like a parabolic PDE. Now, what if 1 minus xt is less than 0? What does it mean? It means that this implies that 1 is less than xt. It means that xt is greater than 1. So if this xt is greater than 1, what will happen? 1 minus something greater than 1 will make it negative. So the equation will become elliptic, right? When 1 is less xt is greater than 1, so the equation will be elliptic because whole of the function b square minus 4ac will be negative, right? And the last is if 1 is greater than xt or xt is less than 1. So what will happen if xt is less than 1? If xt is less than 1, so in this equation, this whole value will be positive, will remain positive, will always remain positive. So xt is less than 1 but not equals to 0, right? Because we already have taken equals to 0. So xt is greater than 1, so the equation will be positive and it will be hyperbolic. Right, so you guys understand now how this is working, right? So we can check the behavior of these equations in this manner. Checking b squared minus 4ac, that is also called discriminant. That is called discriminant because it discriminates the equations. It classifies the equations into their respective classes. So let's take another example. Let's say a question is given: x times u dt plus t times u xt plus u xx is equals to 0. Right, so a is equals to x, b is equals to t, this coefficient, and then c is equals to 1, that is this coefficient, right? So now we can apply the discriminant, that is b squared minus 4ac, right? So this implies that t squared minus 4x. Now again, we have to check that how this will work, right? If t squared is equals to 4x, it means that this equation is equals to 0. B square minus 4ac is equals to 0, so it will be parabolic. So you can see the variable coefficients are basically the determining factor of the respective classes of these differential equations, because we can see that this variable, we don't know that it has a specific value or not. These are variables, so we just have to uh, find the required conditions. So when t squared is equals to 4x, this will happen. It will be parabolic because this will be equals to 0. When t squared minus 4x is less than 0, this implies that t squared is less than 4x. And when t squared will be uh, less than 4x, what does it mean? When t squared will be less than 4x, so it will be uh, negative value, right? Because t is equals to negative 4x, and so sorry, t is less than 4x, and 4x is with negative sign. It means that 4x is bigger than 4x. The value of 4x magnitude, you can say it's bigger than this t squared, so it will be negative, and we can call it as elliptic equations. All right. And then if t squared minus 4x is greater than 0, this implies that t squared is greater than 4x. So if t squared is greater than 4x, like this value is greater than this value, so this is positive value and this is negative, so it will be always greater than 0. So what does it mean? That it means that this will be a hyperbolic PD. So you guys see, we solve a lot of problems on the classification of second order partial differential equation, specifically having two independent variables, involving two independent variables, and we classified them into three classes, that is parabolic, hyperbolic, and elliptic equations. So hope you guys understood the lecture and enjoyed the video. So stay tuned for the next video lessons. We'll talk about some canonical forms in the next lectures. So goodbye till then.